Hello, I'm Mikhail Raskin and I will tell you about Lisp in the middle and using Lisp to manage a Linux system. So what Lisp in the middle does? It uses common Lisp to do some random tasks related to managing a GNU Linux system. One thing it does for system management, which is often omitted but sometimes included, is isolation some of the programs so that they can be treated more like components which do not interact until explicitly asked to. What tools it uses? Well, at the core it is Common Lisp and the policies are written in Common Lisp, but then there is some amount of Bash mixed with Common Lisp in outer layers. How it does it? Well, lazily, and lazily here applies to me as a programmer and not to lazy evaluation. Why did I bother? Well, first of all, there are a lot of small changes that I wanted, and then it was a question whether it is easier to design a system where they are natural than to patch them in existing systems. Too many things change upstream that I didn't want to change, actually, and here Common Lisp is attractive because software in Common Lisp usually doesn't really change much and just keeps working the same. And what encouraged me is that the hard part of the upstream code are the things that I actually don't use anyway, so I could just skip them. And what to expect at the current talk? Well, I will show you how it looks like, although there is not much that can look like anything there. I will walk through what happens behind the curtain, so to say, when this demo runs. I will give you a brief overview of what else is there and is nice to have, and also admit what isn't there, even though maybe it should be there. And I will try to share the lessons I have learned for this, and maybe some of them would be interesting or inspiring to you. Let's start with a little demo. You will see why I am filming my laptop screen instead of capturing it with OBS in a minute. I want to show you what I do when I disconnect my laptop from a power source from a long time and want to reconfigure it to reduce the power consumption. I use Rofi to select a saved Lisp form to evaluate, and in this case, when I disconnect, it will be disconnect function invocation. As you see, there are quite a few saved invocations with different parameters. However, for simplicity and to walk through step by step, let's just look at a simpler call which only sets screen brightness and CPU frequency. So it is ask with auth macro invocation with the body of set CPU frequency mean and set brightness 1. So it will be evaluated by starting a new unprivileged Lisp image and passing it this code to evaluate. So what happens when I do evaluate it? As you see, the screen changes. It's no longer actually a session. It's now a virtual terminal with FBterm, and I'm shown what I'm asking to do. And when I press enter, you can see that the screen is now darker, and given how the laptop screens regulate the backlight, you see that my phone now has problems focusing on the laptop screen. I guess now it is clear why I ended up just filming the laptop screen, because on the one hand I want a virtual terminal switch, which is not very compatible with OBS grabbing, and on the other hand I didn't want to just run it in a virtual machine because I wanted a privileged operation which is also visible, like screen brightness change. Another demo is related to how I run Firefox in isolated environments. We evaluate the following form. It's a function call to the Firefox function with the list of things to pass to Firefox on command line, which is just the URL of the European Lisp Symposium web page for this year, and also isolation parameter column data, which specifies the path to the directory with the materials for the current paper and slides for the current presentation. And what happens when we run it? Of course, Firefox window appears as expected with the expected web page, but let's look around to see what is the environment in which this Firefox instance runs. We use the open file dialog of Firefox to look around. And first of all, we will look into the home directory, and it is something temporary, and it is also empty, and it also lives in /tmp. And where is the real home? Let's go to the top level. Slash home is just not there. So if there is a file disclosure vulnerability in Firefox, it will not reach the real home, and also the false home is simply empty. On the other hand, there is this underscore data directory on the top level, and if you look inside of it, we will see that it is indeed the specified directory with the materials for the current paper and current talk. So you see that we show what we want to be shown to the application with conveniently short path, and we hide what we don't want the application to see, and also there is no place where data could persist between the runs. Just for avoidance of the doubt, each instance is launched with a fresh copy of the empty profile so that different runs do not interact. So what happens behind the scene in the demo? So the user, as you have seen, evaluates the following form in the unprivileged Lisp image. And ask_with_auth is a macro which tells the system that it should request a privileged operation from the system management daemon. And the content of the requests is enumerated below, so it's set CPU frequency mean and set brightness 1. However, the requests listed are actually not what gets sent, because the protocol requires that the contents of the lists is either strings or numbers. Only nil is allowed as a symbol. The nice property is that it looks the same in all the Lisps, and I did some proof of concept playing with Guile, and also it is a bit easier to reason whether it's safe or not safe to pass such a data structure. So the request gets translated by just replacing the symbols with the symbol names. But also it is a privileged operation request, and you have seen that there was this thing about presence t, and so the requests need some authentication. The client process will prove to the server that it has the user ID of, well, me, and also will ask the server to check whether the physically present user agrees with this request. And that's why there was this virtual terminal switch. And then how it will go about the first part, about user ID. It will send to the server request user ID authentication for the user Raskin. Then the server will send back the file name, and the file is such that only the client with the user ID Raskin can read it, and the client process will of course read this file. And then the client process will use the value read from the file to send the form authenticated for coming from user ID Raskin. So it will send with user ID authentication and then this password. And then, as the presence authentication has also been requested, it will just tell the server to perform the presence authentication, and then pass the list of the things to do to authenticate at once and then perform, and also the timeout for requesting reaction from the user. So when server receives the request, it takes the string from the top level list of the request and takes the first argument and then turns it into the socket command server commands package, and just executes this function, passing it as the first argument context, for example, whether the user has confirmed already something or not, and stuff like that, and also passes it the remainder of the request. So on the top level we have this check whether the password has been read correctly, and then we have this check which asks the user, and then there is set CPU frequency which gets parameters context and mean, and the two parts of the function set CPU frequency is first it checks policy whether it is enough that the user has pressed enter when presented with the question should we change the frequency, or whether something else has to be checked to proceed. And the second part is the actual implementation calling the function which changes the CPU frequency. And by the way, as the protocol supports only passing strings and not symbols, that means that you cannot pass keywords, and that means that if you have any keyword arguments to the function which does the actual work, you need to have explicit translation between strings and keywords, so it is more visible, and so it is a bit harder to forget if you need to filter and only allow some of the keyword arguments to be specified. Well, and once the server has decided what to do and whether to do it, if it decides that the request should be executed, well, in that case it actually executes the request. One thing that happens in a system, in addition to changing screen brightness and launching Firefox, is that sometimes the system needs to be updated, so a fresh version of SBCL or maybe Vim or maybe Bash can be installed. And then, of course, I would want, as I said, to have some amount of isolating the concerns. I want, of course, the management of persistent state to not be a thing I need to think about too much, so the persistent state changes should be predictable. And the normal approach to managing what software is installed is basically a lot of global mutable state, because you have these installed packages and then you say that, oh, I want to install a new version of everything, or maybe I want to install a new version of this package, and then the system package manager tries to look at the current state and tries to look at the new versions and tries to look at the things which are staying at the old versions and tries to build a configuration which would satisfy all that using such solvers. And for predictability, I would prefer something which in Lisp terms would be closer to constructing a fresh list out of fresh const cells than to destructively modifying the old list. And so I want my packages to be immutable data structures referring to each other, and this is provided by at least two package managers. I know of Nix and Geeks, and Geeks was originally a fork of Nix with rewriting more and more things into Guile, and now it is, as far as I know, completely independent code base. And I would recommend Geeks to any of you who is interested in this approach to this functional programming style package manager, but I still use Nix because of ease of package availability if I want to run the entire system from the same package repository. But okay, so I have installed a new version of SBCL, and maybe I have even installed a new version of policy in terms of what is allowed, what is not allowed, whether it isn't enough that the physically present user just presses enter to change the screen brightness and stuff like that. And now I need to update this daemon to make sure that it follows the fresh policy and follows my current opinion, what I wanted to do. So how do I do it? Well, I just exit the daemon or crash the daemon if I feel especially destructive, and let it automatically restart. Of course, as the daemon manages the runtime of the system, there might be some runtime state it tries to keep track of. Some of the runtime state of the system doesn't need tracking because kernel remembers IP addresses and things like that. But some things need to be preserved, and for this I use an SQLite database on a memory-based file system. So it is, if I want to ensure it is runtime only, it is on a memory-based file system, so it gets wiped on reboot. And this means I don't have any expectation of perfection of policy code. I can experiment with it because crashes are fine. I intend updating to be based on crashing, and also experiment can end up in a crash, and that's fine. And also it means that I can integrate multiple daemons if I wish to. So what else is there? Well, some requests are authorized automatically, some requests require the user to just press enter, some can even require to enter a root password. For example, updating the system does require to a new version does require to enter root password. And another service provided is that if the daemon already knows how to ask the user to enter a password in a virtual terminal, then it can be used for a generic password entry for an arbitrary user program in the dedicated virtual terminal, so that there is no question of how different programs in the same X session can intercept the input. And you have seen that I have this ripening Firefox to run in an isolated environment, and if you run a command line tool inside an isolated environment, then its terminal input and output just can be forwarded to the terminal where you launched the program. And also one more small thing I want to mention is shelf mount devices, which is my solution how to handle removable devices in a Lisp way and also in a convenient way. And the idea is that you can ask to run some program, usually a shell, and mount some removable device like a USB drive beforehand. And as long as this shell or any of the descendants of this shell still run, the device stays mounted, but as soon as all of the descendants of this shell, including the shell itself, exit, the request to unmount the removable device is immediately sent to the system management daemon. And of course, this is just something I wanted to highlight. There are quite a few more small things similar to those. But I guess it's pointless to enumerate all the small things that I use. And of course there are some things that should be there, but I never get around to adding them, and they don't annoy me enough, although maybe they should. First of all, of course, if an arbitrary program can force the switch to this special virtual terminal to request user confirmation, this can be used to annoy user, you can say even as a denial of service attack on the computer. And I have some ideas how to mitigate this, but well, I haven't yet gotten around to implement any of these. There should be more options what can be reliably established about the requesting process, like maybe process ID and the command line, and making sure that you cannot spoof it by sending request and immediately executing some program with exec with the same process ID. And maybe another thing which is kind of a part of this is maybe I should even add the system calls to ask who is on the other side of the local socket to IOLib, because it doesn't fully support this requests of who is on the other side, although it does support sending file descriptors and credentials over the socket. Maybe it would be a good idea to have some JSON-based or XML-based protocol as an alternative to the S-expression-based protocol for easier interaction with the non-Lisps on the other side. Of course, in the modern world, like I have a lot of Unix computers that I use in one sense or another, like my laptop, and then there is my handheld device, and then there are some virtual private servers and whatever, and maybe some multi-device support for managing a herd of systems could be nice. And speaking of supervising a collection of things, also I don't actually have any kind of service supervision, and maybe I should integrate with Shepherd or something like that to have service supervision support, so that I can control what daemons fail and restart them. It just so happens that right now I only want to run daemons which don't fail on their own without reason. So what have I learned from all this experience, and what I hope to tell you, maybe as a useful curiosity or maybe as an inspiration? First of all, it is indeed not that hard to move the decision, at least the decisions in managing a Linux system, into Lisp code. I was kind of optimistic, but well, my optimism matched the reality, and then you can just grow the scope as desired. You can move more and more things into Lisp if you feel that moving them there makes sense. A kind of negative discovery, on the other hand, is it turns out that there are some workflows that I still prefer to run in POSIX shell somehow. And just because of small ergonomics or whatever, but I prefer to run them in POSIX shell and not in Lisp REPL. And as a pair thing to that, which might be useful to know, SBCL REPL doesn't promise to be a good shell for starting interactive programs, and there are some small things which make it indeed sometimes a bad idea to start interactive command line programs from SBCL REPL, which also adds to my tendency to still use POSIX shell more than my tooling would allow me to. One more thing is that when trying to write idiomatic Lisp code, you can just discover what things were missing from the user interfaces you were using before. Because on the one hand, it's completely natural to ask, okay, I want to mount this USB drive just for the time I need to run this program. But somehow I haven't seen it in too many desktop environments. I'm not sure I have ever heard of this feature in a desktop environment, however natural it is. On the other hand, if you try to think in terms of case, so what is missing from my Lisp library, this is a completely natural feature, and like what else could you even want? Why would you not want it? So maybe the lesson learned here is that cross-checking the idioms from different environments and different languages could be useful when looking what you need in your interface, be it programmatic interface or user interface. And the slightly unsettling lesson learned is that the more I use the computers and the more I customize my environment, the more my comfort of using computers depends on more and more idiosyncratic tooling, usually with parts which I write myself, which is on one hand nice because this tooling solves the problems I do feel I have, but on the other hand it's kind of scary in more than one way. Thank you for your attention. Are there any questions?